common question when looking at mechanisms is, what's the gear ratio? Well, it's pretty simple. To figure out the gear ratio, you're going to do some simple math. The first step is to look at each gear and count how many teeth are on that gear. In our smaller gear on the right side, I've counted and we have 12 teeth. On our bigger gear on the left, I counted 24. Now, what you're going to do with your 12 teeth and your 24 teeth is you're going to turn them into a ratio or a fraction. Now, when you turn these into a fraction, like all fractions, the order of the fractions matters, or the order of the numbers. So the really weird thing about when we look at gear ratios on a mechanism is we actually put the output on top of the fraction and the input goes on the bottom. Now, how do I know which is my output and which is my input? Well, in this case, this is my input gear because I have my hand crank for this mechanism on this gear. So the hand crank implies that this would be my input. If you're looking at a bike, a real life application, the input on a bike chain would be where you pedal. So we can just pretend that this is a foot pedal. This is my input. So this gear, 12, goes on the bottom and 24 goes on the top. So here is what I'm going to do. I'm going to put my output over my input. I'm going to plug in my numbers. 24 over 12. 24 over 12. Now, like math, we still have another step. Never would we put a fraction in on a math class with a fraction of 24 over 12. Your math teacher would ask you to simplify it. You have to do the same thing with gear ratios. So you're going to take that 12 over 24 and you'd be like, oh my gosh, that's super easy. That simplifies down to 2 over 1. Why is it super easy? Because 12 goes into 24 2 times evenly. So your gear ratio would be a fraction of 2 over 1. But when we're talking about gear ratios and when we put our gear ratios in and record them on paper or on your quiz for class, you're not going to put in a fraction of 2 over 1. What you need to do is write it in gear ratio format. The gear ratio for this mechanism would be 2 to 1. So you would say 2 to 1, but you type on your quiz or in a written form 2:1. An engineer would say 2 to 1. We would solve it as 2 over 1, and we record it or we write it as 2:1. So why do gear ratios matter? We've already found out that this mechanism has a gear ratio of 2 to 1. It has a gear ratio of 2 to 1 because we're comparing that this tooth or this gear has 24 teeth, this gear has 12 teeth. We simplified it down, and this is how an engineer records it. But what does that really mean? Why would we want to have 2 different size gears? What do we do with that? Well, it has everything to do with the purpose of this mechanism, and that is to either change speed or to change torque. Changing speed means this gear will make this gear turn at a different rate. Now that's a little tricky to see just looking at the gears. So I'm just going to grab another hand crank. I'm going to put that up. I'm going to slide this hand crank on, and you can see when I add another hand crank, that hand crank on my output is now spinning at a different speed. So the question is, does this mechanism increase or decrease the speed? Does it go faster from the input to the output, or does it go slower? Let's take that off. This is my input. This is my output. Is my speed increasing, or is my speed decreasing? Hopefully, after observation, you see that this gear is spinning faster and this gear is spinning slower. So we would say that this mechanism, this chain drive with these specific gears and a gear ratio of 2 to 1, we decrease the speed. So we found out that this mechanism with a gear ratio of 2 to 1 is actually slowing down. This gear is making this gear spin slower. Now, for some of you might be thinking, well, that seems silly. Why would I want this gear to make this gear spin slower? What would be the advantage of that? Why would I want to have a mechanism decrease the speed? That's weird. Well, it has everything to do with the opposite thing that happens in a mechanism. We have two things that happen. We can either change speed, or we can change something that's not visible called torque. Torque is what gives us the power to do things. And the cool thing is with a mechanism, if you decrease the speed, like the wings of an airplane, the opposite thing in our mechanism, torque, has to go up. So that means in this mechanism, when our speed goes down, our torque, or the amount of work or strength in that mechanism, actually increases. Now the weird thing is we can't see torque, we just have to know that it is there. If you've ever been biking up a hill and you think, oh snap, I can't get up this hill. But if you know how to use the gears on your bike, if you change gears, you can make it a lot easier to get up that hill by changing the amount of torque that's available in your bike mechanism, your bike chain. So if we have a gear ratio of 2 to 1, it's going to decrease the speed, but it's going to increase the torque. So in this specific mechanism, we can see the output gear going slower, but that also tells us that it's more powerful. It has more torque. So we would want a mechanism or a gear ratio of 2 to 1 to help us get up a hill.